Okay, in this video we're going to do questions 5 through 10 of the day 1 homework of 2.5. So question 5 starts out with asking us to find the maximum of, so here's 5, of q equals x times y, and then it says if. If you see an if, that's going to be your constraint. X plus y equals 2 is the constraint. So if this is your constraint, you're going to use this constraint to find the maximum, and that's your tip-off. That's what your job is. That's what your objective is. You're going to use your constraint to find the maximum of this by putting it into only one variable. So let's write q equals x, and instead of putting y in, let's redefine y as y equals 2 minus x. You see where I got that from the constraint? So here I need a product, so I'm going to say 2 minus x. Now I have my objective function in only one variable, and I multiply it out and I get that. Now you're ready to go. Now we're exactly where we were for the previous problems. Here is a downward facing parabola. It's going to look like this. I want to find the maximum. It's going to occur right here at xcv. Okay, so they want me to find the maximum. The only answer they want from me is this q max. So let's get that. Let's get that q max by first taking the first derivative of my objective function. So I get 2 minus 2x. I'm going to take the second derivative so I can evaluate it. That's a negative 2. If it's negative, I know my function is concave down. And since there's no x involved, I know it's concave down throughout the function. So the xcv that I get will result in a max of the q. Set your first derivative equal to 0, and you should get x equals 1. So if x equals 1, if my goal is to find what q equals, I have to first know what y equals, since q is the product of x and y. Or what I could just do if I wanted to, since they don't ask me for y, is go ahead and plug your 1 right here and right here. And what do I get? So if q equals x times 2 minus x, and if x equals 1, then it looks to me like 1 times 1 is 1, and that's my value for q, and I am done. And then you're going to write a statement saying that since you have a second derivative right here that was negative throughout the function, I know that that critical value has given me a maximum of the q. And I got the q by doing the product of x and y. And I used the y written in terms of x. And there you're done. So let's go on to question 8 on the next slide. Okay, let's go back and look at question 6 for a second. So question 6 says, find two positive numbers, x and y, that maximize q equals x squared y if x plus y equals 2. Okay, so we want to maximize q equals x squared y, and then we have if x plus y equals 2. So the if part is your constraint. This part is your objective function. You're in two variables right now, so we're going to use our constraint to replace. It looks like the y is best to replace. Y equals 2 minus x. Okay, so let's write our objective function in terms of one variable, and that variable will be x. So there's x squared. Now I'm going to replace the y, and I get q equals 2x squared minus x cubed. go ahead and take the first derivative. That gives me 4x minus 3x squared. Taking the second derivative for my test, 4 minus 6x. Okay, so now what do I know? It says find two positive numbers. Okay, if this is a positive number, if it's positive 1, my q prime prime is negative. If it's positive 2, it's negative. So this q prime prime will always be negative. If it's negative, I know that I have found a max. So that's good news. So now let's go ahead and we're going to find the two values. So let's set our first derivative equal to 0. And because I have two x's, we're going to factor. So I'm going to say x is the common factor, and then I have 4 minus 3x. So my answers are x equals 0, which I know I can't have because they want x to be positive, or I have 4 equals 3x, and therefore 4/3 equals x. Okay, that's going to be one of my choices. And then what else do I have? So I'm going to now figure out what my y is. So let me just change colors so you can see what I'm doing. Okay, let's come back up here, and if y equals 2 minus x, then let's put this x that we just found right here. So that's 4/3. Now I can't subtract those because they don't have the same denominator. So isn't 2 the same as 6/3? So let's erase the 2 and let's make the 2 6/3. And now I can subtract those. So given that, y will be 2/3. So now I have two answers. X equals 4/3 and y equals 2/3. And I already did my second derivative test, and I said the information, you would write it, but those are my two answers, and I know I have a max because of that second derivative test. Okay, let's go on and we'll do question number 7. Okay, in question number 7, so this is 7, it says find the minimum of q, and q equals x squared plus y squared, if x plus y equals 6. Okay, so we know the drill. Take your objective function, which is what you have to find the minimum of. So I have q equals x squared plus y squared, but let's replace the y. So what's y equal? Looks like it's 6 minus x. So it's x squared plus 6 minus x squared. So we're going to have to FOIL that. So q equals x squared plus, now let's put a little bracket here. So I'm going to get 36, and then it looks like I'm going to have negative 12x plus x squared. Okay, so that's question number 6 written out, number 7 written out in expanded form. Now we're going to try to make it so that I'm going to take the derivative. So I'm first going to combine all my like terms. So when I do that, I get the following. So I have q equals, here's an x squared, whoops, here's an x squared, here's an x squared. So let's say q equals 2x squared. Then let's do it in standard form. So I'm going to say minus 12x plus 36. Okay, now I am ready to take the first derivative, because that's what I'm going to do to maximize or to optimize this problem, because I'm trying to find the minimum. Okay, so I get 4x minus 12 for my first derivative, and I get 4 for my second derivative. Since the 4 is positive, I know that my second derivative will yield an x, will yield a minimum for q at the x that makes my slope equal to 0. And that x will be 3 if I set 4x equal to 12, I get x equals 3. Let's go back and read our problem. So what are we trying to find? It says find the minimum of q. Okay, so I have the x critical value of 3. How will I get the y critical value? Well, I can just plug in. So I'm going to change colors again. Right here I had y equals 6 minus x. So 6 minus 3 makes y equal to 3. So y equals 3. Okay, go back up to your original equation, and now let's get our value for q. So q equals x squared plus y squared, and x squared would be 3 squared, y squared is also 3 squared, so 9 plus 9 is 18. Q is at a minimum value when q equals 18, and that is the answer they're looking for. And I have substantiated it with this second derivative test, and I would write a comment about that. Okay, let's go on to question number 8. Okay, question number 8, which I'll put down here in a different color, asks us to look at this problem and say, we know that we have just minimized it. Can we maximize it? And the answer is no, you cannot, because when you have the second derivative, it tells me that the second derivative is always going to be concave up, and therefore my vertex will always be at a minimum when I want to optimize. However, one qualification would be this. If, let's just say for argument's sake, that our function, and it doesn't look like this, but let's just say it looked like something like this. Okay, if I had endpoints, and say I said, okay, we're going to maximize this function over these endpoints, and I'm just going to pick random numbers, 2 to 9. I would say that if you check your endpoints, we don't have a maximum that is a vertex, but we could get a maximum value, and that maximum value will occur at the endpoint of 9 in this situation. So I would have to give you limits if I wanted you to make a comment about a maximum value for a function that is always concave up. Okay, the maximum value would just be the value at one of the endpoints. We're not going to do that in this exercise, but going in the future we might have a problem, something like that. Okay, so 8, the answer with your current knowledge and with this current problem is no. There is no max, there is only a minimum. Okay, let's move on to question number 9. All right, the question for 9 says, find the positive values of x and y. So I'm going to add the fact that x has to be greater than 0 and y has to be greater than 0 to this problem, based on that little statement. So find the positive values of x and y that minimize s equals x plus y. So we want to minimize this, so therefore that's my objective function. Okay, and then it says if xy equals 36. So if tells me that that is my constraint. So really, because of the positive feature, all of these things are my constraints. So those are constraints. I'm not going to explicitly put in the constraints that x is greater than 0 or y is greater than 0, but I'm going to remember that as I go to minimize this. So once again, take your objective function. It's a simple addition. You cannot have two variables, so I'm going to have y equals 36 over x using my constraint. So I'm going to write that as 36 times x to the negative 1, because that's prepared now to be taken a derivative of. So s prime equals 1 minus 36 x to the negative 2. Let's take our second derivative. equals positive 72x to the negative 3. Okay, so what do I know? Well, x to the negative 3 is better off written as x to the third with that in the denominator. So let's go ahead and we'll move x to the negative 3 right down to this denominator. Okay, what do I know about that value now? Since x has to be positive because of my implied constraints, I know that that value is always going to be positive. If it's always positive, the x value that I find when I set my first derivative equal to 0 will result in an x that minimizes my objective function of s equals x plus y. Okay, so I know I'm going to find a minimum. Now, I'm going to set my first derivative equal to 0. Okay, so now down here, so let's change colors so we can see what we're doing. Down here I'm going to say y minus 36 x to the negative 2 equals 0. Now, x to the negative 2 does not help me up there. That is just confusing. So I'm going to take that x to the negative 2 and I'm going to put it in the denominator as a positive exponent. Now that makes a lot more sense. So I have 1 equals 36 over x squared. You basically have fraction equal to fraction. That means you can do your cross products and set them equal. And that will give me x equals plus and minus 6. But because I know my x has to be positive, I'm only going to take the principal root of positive 6. Now I'm going to go back again to the question. Find the positive values of x and y that minimize that objective function, and then also I need to find this minimum value. So I need 2 more answers. So up here, if I plug an x right here with a value of 6, 36 divided by x gives me 6. So therefore I know that y has to be 6. And since my objective function asked me to add them, I know that my objective function will be s equals 6 plus 6, which is 12. So those are my 3 answers, and then perhaps you'd want to write out a little statement here about your objective function resulting, your second derivative resulting in a positive value which verifies that you have found a minimum. And those are your answers. So a good takeaway from problem number 9 is that you want to use negative exponents when you're taking derivatives, and don't use negative exponents when you're evaluating your function. Okay, be able to change your equation or your expression so that it conforms to what you need to determine from it. So therefore, if you want to figure out a value, having a negative exponent just makes it more complicated. Okay, let's go on to number 10. All right, in question number 10, they say that we want to find the positive values of x, y, and z that maximize this function. Since the word maximize is used with this function, that's my objective function. Since the word if is used for this, these are my constraints. So we now know the objective function and the constraints. So they want the x, y, and z, but they also want the maximum value. So just like before, we need to make sure that we write our objective function only in one variable. It's in 3 variables right now. So let's start playing around with our objective, with our constraints. So looking at your constraints, I can see that y equals 1 minus x and z equals 2 minus y. So now I'm thinking, how does that help me? And then I say, oh, wait a second. Can't I say, since z is 2 minus y, isn't z 2 minus 1 minus x? So since I know I have y as 1 minus x, I substitute it in the z equation, and I end up getting that z equals 2 minus 1 is 1, and minus a minus x is plus x. So here are my two equations. If I substitute out the y and the z, I will have everything in terms of x. So q equals x times, the y was 1 minus x, and the z is 1 plus x. Okay, so q equals x, FOIL your 1 minus x, 1 plus x. You should recognize that as the factored form of the difference of perfect squares. And if I FOIL it, I will get 1 minus x squared. Okay, one more step, and I'm ready to take the derivative. X minus x cubed. So q prime equals 1 minus 3x squared, and q prime prime equals minus 6x. Since I know that x has to be positive from the wording of the question, then I know that q prime prime will be negative. If it's negative, I have found the maximum of q by solving for the critical value of x. Okay, so now let's do that. We're going to set that first derivative equal to 0. So let me just change colors at this point. Okay, so we have all our work up here. Now let's get our critical value. So 1 equals 3x squared. So 1/3 equals x squared, and I'm going to switch it around. So x equals plus and minus radical 1 over radical 3. But since I can't have negative values, and since the square root of 1 is 1, my x value is 1 over root 3. So far I have x equals 1 over root 3. That's my exact value. What does y equal? Well, y equals 1 minus x, so y will be 1 minus 1 over root 3. And then look what z is. Z is 1 plus x, so that's 1 plus 1 over root 3. And then what's our product going to be? So q equals 1 over root 3 times 1 minus 1 over root 3 times 1 plus 1 over root 3. I think I'm just going to leave it, well, I think I'm going to leave it like that just in the interest of space. Well, maybe I'll go one more step. So q will equal 1 over root 3. If I FOIL that, I'm going to get 1 minus 1 over, what? So let's see, if I square that, 1 over 3, which is 2/3, right? So my q will be 2 over 3 root 3. Okay, and that's